sorry, note to self, low battery notifications, cut the video off. As I was saying, a 12 molar solution, that's really, really dangerous of an acid like hydrochloric acid. So do you think that we're ever going to do any labs with that 12 molar solution? Probably not. Labs that we do probably don't have more than 1 molar. If anything, they're 0.05 molar solutions or something like that. And how do I get that? I dilute them. Okay, I start with something really concentrated and I add more solvent or more water to the solutions until I get the concentration that I want or that we need for our lab in particular. And this overall process, of course, is called a dilution. Okay, now a lot of these we're always going to be adding water. Just about every single chemical, as we said before in my stock room, is the solvent is water for them. So when we're talking about dilution and changing volume and stuff like that, adding solvent, we're always talking about adding water. So let's say we have a 6 molar solution of hydrochloric acid and it's being diluted by adding water. Let's think about what is going to change. So if I have a 6 molar solution, think back to our definition of molarity. What does that really mean? Well, molarity is moles per liter. So that means I have 6 moles of HCl for every 1 liter of solution. Now, if I go through and I add more H2O, we've got to think about what's going to change. If I add more H2O, is my moles of HCl going to change? No, they're not. They're going to stay the same. Down here, though, if I add more H2O, is the volume of my solution going to change? Yes, it is. It's going to go up because I'm adding more water. Takes up more space. So if my numerator stays the same and my denominator goes up, how is that in turn going to affect my molarity over here? It's going to go down. And if you think about things that you already know, like let's go back to our lemonade example from the other day. If you have a really concentrated lemonade, like really, really sugary or something like that, how do you fix that? Add more water. You water it down and dilute it. By adding more water, your solvent, you make the concentration go down. Okay? Now, these calculations come from one new formula, which is M1V1 equals M2V2. I hope that is ringing gas laws in your head because it's really similar to some of the ones that we did a couple weeks ago. But this is a completely different application, of course. M1 is my initial molarity. V1 is our initial volume. M2 is our final molarity, and V2 is our final volume. So essentially what this is telling us is that if I have a certain concentration and volume of a solution before a dilution, and I know either the final concentration that I want, I can calculate how much volume I need to add, or if I know how much volume has been added to my initial amount, I can figure out what that final concentration is. So this over here, our final stuff is after the dilution is over.